Hello, my name is Dr. Uli Hansen and I welcome you to the video presentation of MSG Lithoglass. Today's talk will be about enhanced light extraction for UV LEDs by SMD-Packaging with integrated reflectors. First, let me introduce Lithoglass. We were founded in 2006 and we have two sites in Germany. Our headquarters and production are in Dresden and we maintain an R&D corporation in Berlin. Both sites are ISO 9001 certified since 2011. Now, we develop and commercialize innovative wafer-level packaging techniques with a target to use these in SMD and COB type of packages. For this, we maintain a specialized foundry service and our focus are optoelectronics and MEMS. Now, here you see a couple of products that we make. These range from wafer-level capping over microstructured glass substrates, cavity wafers in silicon, glass, or in compound window wafers, or silicon-based reflectors. Among the processes that we offer in our foundry are wafer bonding services, low-temperature glass deposition, wet etching of glass, silicon, and other materials, as well as metallization processes, laser structuring, dicing, and others. Now, the application focus is, as said, to enable miniaturized, hermetic, SMD-compatible packages with the aim to enhance optical performance. Using the semiconductor MEMS technologies, we achieve excellent precision, and working on wafer level, we have a high scalability of our products. In terms of applications, these are typically for packaging of sensors, detectors, image sensors, but also emitters like laser diodes, or the UV LEDs that we want to talk about in more detail today. In the field of UV LED, we have several offerings. First are silica lids. So this is basically a drop-in solution for the current packaging. You have a 3D structured ceramic cup in which the LED is assembled, and the lid with anti-reflective coatings and the metallization for soldering can be attached hermetically to this ceramic package. Now, more specialized and customized are lids that have a silica lid, but also a silica sidewall. We call these silica windows with a cavity that allow you to use a flat step mount on which the LED is already placed. And then these lids, again furnished with anti-reflective coatings or solderable metallization, are placed over the LED. Similar but more sophisticated are our reflector windows. Again, you can use a flat step mount with the LED placed on top, and then this window will be placed over this assembly, and the reflector windows integrate mirrors in the sidewalls that allow you to enhance light extraction. Again, we can integrate anti-reflective coatings or metallizations for hermetic attachment. Now, this is what these products look like in more detail and an example of a package, and I would like to give you some more insight on the reflector packaging. Now, what you see here is basically a silicon-based reflector, which we then coat with a highly reflective aluminum coating for the mirror. And then this, on wafer level, of course, is joined together with a fused silica lid for high transparency in the UV range. These reflector caps can be furnished with a gold finish on the backside that will allow you to use solder techniques for hermetic attachment. Now, this is used with, as I said, a flat step mount with the LED mounted on top. And the window will then go over this LED with the reflectors right at the side to the LED, redirecting the side emitted light towards the top. Now, in ray tracing, this is what it looks like using the conventional package. The LED, due to being a flip chip device, emits a lot of light to the side, which is then lost in the sidewalls and turned into heat, heating up the whole package. Using a reflector, this side emitted light is redirected towards the top. So we have typically about 20% higher light extraction compared to the conventional packages. And on top of that, the reflector enables a better thermal performance because less light is turned into heat. terms of light shaping, with a reflector height, which is standard of 0.5 degree, this is the radiation pattern you will get. And looking on the left, you can see that you already have a centering of the light emission. Now, increasing the reflector height, for instance, to 0.7 millimeters will show you that this peak rises, and going even higher to a millimeter, we can have about 50% higher center emission compared to bare dye. And in the radiation pattern, you can see how the emission narrows. So next to single packages, array packaging is always of interest to generate higher power. Conventionally, you would use several LEDs in a single package, or you would place packaged LEDs in array format into a module. Now, with our technology, it is easily possible to have a reflector array in one package. So each single LED will have its individual reflector, maximizing its light output, but also having the advantage that the single LEDs cannot shine light onto each other. So they're optically insulated, again, improving thermal performance of the array package. And with the technologies that we use, customization of the design is easily possible. Now, summarizing what I have presented here, windows for UV LED packaging with integrated reflectors, which allow a much higher light extraction and a better thermal performance. Due to the technologies used, very small outlines are feasible, array packages are feasible, and depending on how the lid is attached, it can be a hermetic or a non-hermetic package. With this, I'd like to thank you for your attention. If you are interested to obtain more information, please go to our website, lithoglass.de, or contact us at info@lithoglass.de. Thank you very much.